Okay, question number 1. We've got A is the point with coordinates 2, 10, and B is the point with coordinates 5D. We're told the gradient to 4. Okay, so my gradient is 4. Work out the value of D. Well, to find the gradient, I need to do the change in Y divided by the change in X. Okay, so my change in Y is going to be from D to 10, so I'm going to write that as D take away 10, and my change in X is going to be 5 take away 2. Lovely. Right, we're told the gradient is equal to 4, so I'm just going to make this equal to 4. I've got one unknown that now I can solve for, so I'm just going to simplify this and solve it out. So D minus 10 over 3, 5 take 2 is 3, equals 4. Okay, multiply this through, everything through by 3 to get D. Take away 10 equals 12. I'm now going to add 10 to both sides, okay, which will give me D equals to 22. So I know my answer, D equals 22, will give me a gradient equal to 4. Question number 2 then says Sophia pays £222 for a plane ticket. She also pays €100 airport tax. The exchange rate is £1 to 1.38 euros. Okay, €1.38. What percentage of the total cost of the ticket and the airport tax does Sophia pay for the airport tax? So what I'm actually trying to find from this question is how much of my airport tax, what percentage is that out of my ticket cost and my airport tax? Okay, and we want percent, so we're going to multiply by 100. Lovely. First, we need to combat this issue that we have in that some are in pounds and some are in euros. So my exchange rate is going to be £1 to 1.38 euros. So I know that in order to get everything into pounds, I need to divide by 1.38. So if I've got €100 of airport tax, I can divide this by 1.38 to find out how much that would be in Great British pounds. Now this is a calculator paper, so by all means we're going to use calculators. 100 divided by 1.38 is going to give me, I'm going to press that one to make it into a decimal, 72.46376 and so on. So I'm going to write this as money, so it's going to be £72.46 rounded to that second decimal place. Okay, just move that out of the way. So now that I know the cost of my airport tax in Great British pounds, I'm going to do my total airport tax, which is going to be £72.46 out of my total cost. So that's going to be £222 for the plane ticket, as well as that £72.46 for the tax. Again, I need to multiply this by 100 as it is a percentage. All I'm going to do now is put that into my calculator. So I'm going to find my fraction button, 72.46 in my numerator. I'm going to do 222, add 72.46 in my denominator for my total, and I'm going to multiply this by 100. Okay, nice and simple, which should give me 24 0.6077 and so on %. Now, the question asks us to give our answer correct to 1 decimal place. So now all I need to do is round this number to 1 decimal place, which will give me 24.6% as my final answer. Okay, question number 3. A sofa has 6 identical cushions. Okay, so we know that that's an important fact. Each cushion is a cuboid 18 centimetres by 80 centimetres by 95 centimetres, which they've kindly given us a diagram for here. Okay, the cushions are covered with a protective spray. The protective spray is in cans. The label on each can has this information. So some key information in this box here. Spray in this can covers 4 metres squared. Now, hopefully we've recognised that actually we've got a difference in units here, so I'm going to have to do some conversion at some point. I'm going to do that now. So if we've got 1 metre is 100 centimetres, I am going to divide everything by 100 to have my measurements in metres from the start. So I should get 0.95 metres, 0.8 metres and 0.18 metres for my dimensions, lovely. Okay, next then, the question says, work out how many cans are needed to cover the 6 cushions with protective spray. To cover the 6 cushions gives me the impression that I need to work out the surface area of each cushion. Okay, so this is what we're trying to find. If I look for the surface area, that is the total area of each face on each cushion. So I'm going to have, if I break this down into 3 different shapes, I will have 2 rectangles with the dimensions 0.95 multiplied by 0.18 for this side piece here. I'm then going to also have 2 rectangles with the dimension 0.8 multiplied by 0.18 for these front and back panels. I've then got the top and the bottom, which will be slightly larger rectangles, okay, with dimension 0.8 and 0.95. And as we said with the first one, we've got 2 of each of these. Okay, lovely. Let's move this down. So you pick up marks just for showing that you've attempted to work out the surface area of one of these panels. So let's do that now. 0.95 multiplied by 0.18. Again, I'm going to use my calculator. So 0.95 multiplied by 0.18 is going to give me 0.171, and my units for this one, let's just make sure, are metres squared. So on to the next one, 0.8 multiplied by 0.18 to find the area for the front and the back is going to give me, change that to a decimal, 0.144 metres squared, and then I've got my area for the next one will be 0.95 multiplied by 0.8, which is going to equal 0.76 metres squared. Okay. Right, now that we've found the area of each face and we've got some marks for that, excellent. What I need to do is find the total for one cushion. So, one cushion is going to have 2 areas of 0.171. So I'm going to have 2 times 0.171. I've then also got 2 of two areas of 0.144, and I've got two areas of 0.76. I'm going to put this in my calculator, just making sure that my screen is showing exactly the same as this calculation here. So I'm going to use my brackets, 2 times 0.171, add 2 times 0.144, close my brackets, add 2 times 0.76. Now hopefully this should give me an answer of 2.15 metres squared. Okay, so for one cushion I get a total of 2.15 metres squared surface area. For 6 cushions then, nice and simple. Okay, I need to multiply my one cushion amount by 6. So I'm going to do 6 lots of that 2.15 metres squared surface area. So I'll multiply this by 6, which should give me 12.9 metres squared in total that I need to cover with that spray. If each can, we're told the spray in this can covers 4 metres squared. If each can covers 4 metres squared, I'm going to do 12.9 divided by that 4 metres squared. Okay, which should give me an answer of 3.225 cans that I need. Now I can't have 0.225 of a can, so I would need to buy 4 cans, so therefore 4 cans are needed. So your answer would be 4. Okay, continuing with question 3 then, we're then told for part B that the information on each label is inaccurate. The spray in each can covers 10% more than 4 metres squared. Well, 10% more than 4 metres squared is going to be 4 metres squared multiplied by our 1.1 percentage increase. So we're going to have 4.4 metres squared that is actually covered by each can. The question asks, how will this affect the number of cans needed for the 6 cushions? So how will this affect the number of cans? You must show how you get your answer. So let's just check. We've done our multiplier to find out how much is actually covered by each can, and then we'll go back to our last page, which gives us the total surface area of 12.9 metres squared. So that hasn't changed. I've got 12.9 metres squared. This time each can is 4.4, so we're going to divide it by 4.4 metres squared to see how many cans we need. So if I take my calculator again, I'm going to put 12.9, divide that by 4.4, which should give me 2.9318, both recurring. Okay, this time my number is less than 3, so I know that 3 cans would be enough. So therefore the number of cans needed would be 3, so the amount decreases. Okay, so as long as you're making a comment about the fact that the number of cans you need is less than the number that you needed before, you would get those 2 marks. We're going to have A add B for our column vectors. We just need to add them across, so I'll have 1, 4, add 3, 2 is going to be 4, 6 in total. So that would be my answer for the first part. Then for the second part, I've got 2 lots of A, which is 1, 4. Add my 3 lots of B, which is going to be 3 lots of B, 3, 2, which will expand out to give me 2, 8, add 9, 6, which we can then do exactly as we did before, add them across to give me 11, 14 for my final column vector. You pick up marks for showing the expansion of either of these vectors, so 2 lots of A or 3 lots of B. You pick up a mark there. Lovely. The vector C then is drawn on the grid, so we can see that this is the vector 3, 2. Okay, so this is 3, 2. Then I'm going to need to do the vector 3C will give me 3 lots of 3, 2. So I'm going to have to go across in my X 9 and up in my Y 6. So I'm just going to plot that out now. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 and up 6, 1, 2, 3, 4, 5, 6. So here's my point. If you want to in the actual exam, just check that one over, count it again, make sure that you've done the right amount of spaces. So I'm just going to get my ruler. Okay, so I've got my ruler now. I'm just going to draw that vector in a single straight line, and that would get me the mark. Okay, question number 5, we're told the height, X centimetres, and the width, Y centimetres, of TVs are in the ratio 9 to 16. So this is my X to Y ratio. Use this information to draw a graph to show the relationship between the height and the width of TVs. Use values of X from 20 to 80. Now, what I would suggest we do is we create some coordinates that we can plot. So what we're going to do is, let's just scale this up. Well, if I was to multiply everything by 2 and find an equivalent ratio, 18 doesn't quite reach on this scale. They've been a bit sneaky there. So we're going to multiply by 3 to start with. So I'd get my first coordinate multiplied by 3, which would give me 27, 48. Okay, by 4 would give me 36, 64. And then by 5, you would get 45, 80. I'd recommend doing at least 2 to be able to plot the line, but 3 just to make sure that you're doing it correctly. So then I'm going to go ahead and mark those out on my grid. Let's just make it so you can see a bit more. Okay, I'm going to mark those out on my grid. So 27, 48 is going to be, that's my 27 mark, 48. Watch this scale, it's going up in 2s, not 1s. Okay, so 48 is going to be here. Then I've got 36, 64, so 36, 64 is going to be here. I've then got 45 and 80, which is going to be here. Now that I've got my 3 points plotted, I'm again going to take my ruler and draw that graph, that line on the graph, to show the relationship between these two. Okay, where it says use values of X from 20 to 80, make sure that we're covering the whole width of this graph, okay, right up to 80. What I then need to do, we're asked, a TV has a width of 90 centimetres. Use your graph to work out the height of this TV. So I'm going to find where the width is 90 centimetres and use my line that I've drawn to find that value. Okay, a prediction for that value. So I'm going to find my point at 90, draw a line across, then draw another line, vertically coming down to meet that x-axis, and I should get a value. I've got a value here of 51, so that would be my answer, 51 centimetres for the height of the TV. This question does actually accept any values between 48 to 52 to get you that mark, okay? So if you've got something in the range of 48 to 52, you are correct. Okay, on to question number 6. We have got a trigonometry question here. So I just need to find the value of the height here, x. I can see I've got my theta, I'm told the theta, my angle value. I'm then going to just highlight and label which sides I know. So I know 18 is my hypotenuse. The side that I'm looking for is opposite my angle, so therefore is my opposite side. If I've got O and H, I know that the trigonometric ratio I need is that sine theta is O over H. We're going to rearrange this now that I put it down to show O equals H multiplied by sine theta, and then we're just going to substitute in our values. Again, use your calculator, okay? We've got 18 multiplied by sine 30, my angle. I'm just going to pop this in, 18 sine 30, close my brackets, will give me a value of 9. Okay. Question number 7 now. So we are told a train travels from Madrid to Malaga at an average speed of 183 kilometers per hour. The train leaves Madrid at 0840 and the train arrives at Malaga at 11:28. We need to work out the distance the train travels from Madrid to Malaga. So this is a distance, speed and time question. So I'm just going to draw out my triangle there. Distance, speed and time. Okay, just as a reminder. So I know my speed, we're told my speed is 183 kilometers per hour. The time, we can work out the time between 8:40 and 11:28, which will be 2 hours and 48 minutes. Now what we need to do is make sure that we've got this time in hours, because our speed is given to us per hour. So for the minutes section, this is going to become 48 minutes out of 60 minutes. So we'll find the decimal of that so that it's in hours. So 48 divided by 60 will give us 0.8 hours. So in total, I've got 2.8 hours that I'm travelling for. From my triangle here, I can see distance equals speed multiplied by time. I've got my speed, I've got my time. So all I need to do is my speed, which is 183 kilometers per hour, multiplied by how many hours I'm travelling for, 2.8 hours. And again, going to use my calculator, pop this in. Okay, 183 multiplied by 2.8 should give me a distance of 512.4. Check the speed for units, kilometers. Okay. And that would give you all 3 marks. Okay, question number 8 says a hollow cylinder has a radius of r centimetres and a height of 6 r centimetres. Okay, 3 spheres also with a radius of r centimetres are put into that cylinder. we need to work out the proportion of the cylinder that is not filled by the spheres. Not filled being the key word there. So I'm just going to label up my diagram. I've got a radius of r and a height of 6r. So we're kindly told here the volume of a sphere is 4/3 pi r cubed. What I need to work out though is the volume of my cylinder. So volume of cylinder is going to be my area of my cross section multiplied by my height. Well, the area of a circle is pi r squared multiplied by my height, which is 6r. If we simplify this, we would get 6 pi r cubed. Next, we need to find the volume of 3 of my spheres. So volume of 3 spheres is going to be 3 lots of the volume of a sphere. So 3 lots of 4/3 pi r cubed, which is going to simplify down to 4 pi r cubed. Now, the question asks for the proportion of the cylinder that is not filled by the spheres. So the proportion of the cylinder not filled is going to be the difference between the total volume and the volume that is filled. So I need to find the difference. So 6 pi r cubed, subtract my 4 pi r cubed, is going to give me 2 pi r cubed not filled. The proportion of that out of my total volume, which is my 6 pi r cubed, is going to be 2 pi r cubed out of the 6 pi r cubed. Well, I can cancel 3 my r cubed, and I can cancel 3 my pi, which simplifies down to 2/6, which would simplify further to 1/3 of my cylinder not being filled by those spheres. Okay, part 2 of this question says the height of the cylinder is increased by 2r centimetres. Another sphere of radius r centimetres is put into the cylinder. Malcolm says there is no change in the proportion of the cylinder not filled by the spheres. Is Malcolm correct? And we need to justify our answer. So I think the nicest way to kind of demonstrate this is currently we've got 3 spheres inside of my cylinder, and it looks something like this from the side. So I've got 1, 2, 3 in my cylinder. I know that each of my spheres has a diameter of 2r, okay, 2r, and I've got a total of 6r in height in my cylinder. I get a new height of 8r, and this time I've got 4 spheres in there. Now, because they all have a diameter of 2r still, I know that the same amount of my cylinder will be filled because the proportion between the number of spheres and the relevant height, there's no extra gaps at the top or anything, hasn't changed. Okay, so that's all I need to put. The proportion, so is Malcolm correct? Yes. The proportion between the number of spheres and the height of the cylinder remains constant. And you need that explanation to give yourself the mark. Okay, question number 9 is a ratio question. So we're told the densities of 3 metal alloys, A, B and C, are in the ratio 13 to 15 to 21. So I'm just going to label that up there, A to B to C. Okay, we've got 1 meters cubed of alloy B has a mass of 8,600 kilograms. We need to work out the difference between the mass of 5 meters cubed of alloy A and 3 meters cubed of alloy C. So give your answer correct to 3 significant figures. Well, I'm going to start off by just writing out that ratio again. So I've got A to B to C has a ratio of 13 to 15 to 21. We're told the mass of alloy 1 meter cubed of alloy B is going to be 8,600. This would help us work out the mass of 1 meter cubed of alloy A and alloy C as well. So to do this, I need to first find out how much I've scaled up from 15 to 8,600. So I'm just going to divide 8,600 by 15, which will give me a multiplier of 1,720 over 3, or 573.3 recurring. So I know that whatever I do, I need to multiply my alloys A and alloy C by the same amount. So if I do this now, I'm just going to, in my calculator, multiply by 30 to give me 1 meter cubed. Mass would be 7,453.3 recurring. And then I've got, if I multiply it again, so just get that one back up, multiply that again by 21, I get a slightly nicer number of 12,040 for 1 meter cubed of alloy C. Now, the question doesn't ask us to find the difference between 1 meter cubed, it asks us to find the difference between 5 meters cubed of alloy A and 3 meters cubed of alloy C. So I need to multiply this by 5, so I'll have 5 meters cubed of alloy A is going to be 7,453.3 recurring multiplied by 5, which will give me and then I'm just going to use my recurring button there to find that value, multiply that by 5 to give me 37,266.6 recurring. Then my 3 meters cubed of alloy C is going to be 12,040 multiplied by 3 to give me 36,120. Again, use my calculator for that one. I need to find the difference in these two values. So I'll have 37,266.6 recurring, subtract my 36,120. Okay, I'm going to use my calculator for this one, so I should get a value of 1,146.6 recurring. Let's go back to our question then, just to check. We need to give our answer correct to 3 significant figures. So 1,146.6 recurring to 3 significant figures, we can round to 1,150 kilograms, which is my answer. Okay, question number 10 then. We've got some values here. Write the following numbers in order of size. Start with the smallest number. Now, first sight might look like standard form, but actually some of these values are not written in standard form. What we need to do is correct them so that they are all in the same format. Now, that will give you your first mark. Let's do that. This is the same, multiplying by 10 to the power of 3 is the same as multiplying by 1,000, so I would get 45. Okay, 4.5 times 10 to the minus 3 is the same as dividing by 1,000. I'm just changing all of these into ordinary numbers, which would give me 0.0045. 450 is already an ordinary number, so I don't need to change that one. And then multiplying by 10 to the power of negative 1 is the same as dividing by 10, which would give me 0.045. Okay, that's my first mark. Now that all of these are in the same format, I can put them in order. So, starting with the smallest number, so I want smallest through to largest. I'm going to have my smallest number is this one here. Now the important thing to remember is that I write down my answer in the original format, so I should have 4.5 times 10 to the power of negative 3 to start with. Then I'm going to have 0.45 times 10 to the power of negative 1, which is my next smallest value. So 0.45 times 10 to the power of negative 1. Then I'm going to have 45 is smaller than 450, so I need to write 0.045 times 10